Let's start with an interesting question. Sin theta plus cos theta is equal to x. Prove that sin 4 theta plus cos 4 theta is equal to 2 minus x square minus 1 whole square upon 2. See, there's one thing which I'll be, repeating again and again during this long lecture is that, proving the trigonometric identities is less about trigonometry, but more about the algebra. Lot of algebra is required, and it will help you a lot if you revise the algebraic expansions that you had done in class 9th. So a plus b whole cube, a plus b whole square, a minus b whole cube. So because we'll be doing a lot of algebraic manipulation. For example, in this question, I'll be using this identity that a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. Now, I understand this seems to be tough, but I'll spend some time. We'll be going step by step in understanding this question because a lot of stuff would get clear. So we start with a simple expansion that x plus y whole square is equal to x square plus y square plus 2xy. That is the easiest one. Now, if you look closely at this, if I want the value of x square plus y square, then x square plus y square would be equal to x plus y whole square minus 2xy. So I have found the value of x square plus y square. Now in this, if I put x is equal to a square and y is equal to b square, see what happens. So my x is a square and y is b square. So this would be a square square plus b square square would be equal to a square plus b square whole square minus 2a square b square. Don't worry, I'm still on the question, but there's an expansion which I want to explain before I go forward. So this would be equal to a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. So this is the expansion which I'll be using in this question, that a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. How I'll be using this is how I'll be using it. Here it is written sin 4 sin raised to power 4 theta plus cos 4 theta. So sin 4 theta plus cos 4 theta is equal to sin square theta plus cos square theta whole square minus 2 sin square cos square theta. Now this is, how did I get this result? I got this result by using this expansion, that a4 plus b4, a4 plus b4 equal to a square plus b square whole square minus 2 a square b square. This is the expansion I'll be using when I will be using, when I have to understand what exactly is equal to sin 4 theta plus cos 4 theta. See, in this lecture, intentionally, the questions which I have taken are usually, level 4 or level 5 problems. So if you don't understand any of the question, I request you to go through that question again and try to understand, because a lot of techniques will be learning. Now, sin theta plus cos theta is equal to x. How do I use this? Sin theta plus cos theta is equal to x. Squaring both sides. Sin theta plus cos theta whole square would be equal to x square. Oh, this is simple. Now I open this expansion. This will be equal to sin square theta plus cos square theta plus 2 sin theta cos theta is equal to x square. Now sin square theta plus cos square theta is 1 plus 2 sin theta cos theta is equal to x square. Therefore, sin theta cos theta would equal to x square minus 1 whole upon this 2. So this is the value of sin theta cos theta that I have found. So my sin theta cos theta is equal to x square minus 1 upon 2. Now this is what I'll be using for getting to this result. But before that, I understand that sin 4 theta plus cos 4 theta, sin raised to power 4 theta plus cos raised to power 4 theta is equal to sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta. Now, this part is equal to 1 minus 2 sine square theta cos square theta. Now, if I have the value of sine theta cos theta, then I can put it in this expression, And of course, I have the value of sine theta cos theta. Sine theta cos theta I derived here. So sine theta cos theta is equal to x square minus 1 upon. So let me put this value x square minus 1 upon 2 here. So my sine 4 theta plus cos 4 theta would be equal to 1 minus twice of, and here I'll put the value of sine theta cos theta whole square. See, sine square theta cos square theta can be written as sine theta cos theta whole square. So value of sine theta cos theta is x square minus 1 upon 2. So this value is equal to x square minus 1 upon 2. I'll write it here. X square minus 1 upon 2. X square minus 1 upon 2 whole square. So I hope this is making sense. Finally, this would be equal to 1 minus twice of x square minus 1 whole square upon 2 square. And this would be equal to 1 minus, this 2 will get cancelled by this. So this will be equal to x square minus 1 whole square upon 2. So this is bit difficult question. You might have to look at the solution again. So now what I have proved is that that sine raised to power 4 theta plus cos raised to power 4 theta is equal to 1 minus x square minus 1 of whole square upon 2. Now, let us look at the right side. What do they want? So, it is 2 minus x square minus 1 whole square upon 2. I have got 1 minus x square minus 1 whole square upon 2. I've almost reached the solution. What I'll do is, I'll again manipulate. And I'll write this as, I'll take 2 as LCM. So 2 minus x square minus 1 whole square. And this is what my RHS is. 2 minus x square minus 1 whole square upon 2. 2 minus x square minus 1 whole square upon 2. So, as you look at this question, you'll understand that a lot of manipulation is being required. And this is not a very simple question. You'll have to, unless and until you have practice questions like these, find it tough to directly do this kind of question in board exams. So, but the good thing is that there's a choice available. So this is a good thing. Otherwise, this question directly you try to do this in board exam becomes very difficult. So I'll just take you through the question again because we did a lot of stuff. I'll just spend some time to show you the solution again. The first thing that we did was we derived this result a4 plus b4 is equal to a square plus b square whole square minus 2a square b square. Now, why did we derive this? Because usually we won't remember a expression like this, but this is what we'll require. If you remember this, well and good. And how did I know that I have to use this? Because I saw this sine 4 plus cos 4 theta. Once I saw this, I understood that this is the expansion that would be required. Then what I did was I have sine theta plus cos theta is equal to x. Then I manipulated this. This is how I manipulated it here. So I manipulated it here. This is the result which was given to me. I took it here and I found the value of sine theta cos theta. So value of sine theta cos theta is equal to x square minus 1 upon 2. Now this is the value x square minus 1 upon 2. This is the value which I'll be using. Where? I'll be using this value in this expression. Sine 4 Sin raised to power 4 theta plus cos raised to power 4 theta. Sin raised to power 4 theta plus cos raised to power 4 theta is equal to sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta. This I understand that this is equal to 1. This is equal to 1. Here, once I reach sin square theta cos square theta, I understand that this is equal to sin theta cos theta whole square. I have the value of sin theta cos theta. I put the value of sin theta cos theta here. This is the value of sin theta cos theta. I square it. I multiplied by it by 2 and I put 1 here. Why I am doing this? Because this is 1 minus 2 sin square theta cos square theta. Then I manipulated this x square minus 1 whole square upon 2. See here, one thing that you need to understand, if I have something like this, that 3 upon 4 this pen. If I have a fraction like this, 3 upon 4 whole cube, this can be written as 3 cube upon 4 cube. If I have an expression like this can be written as 3 square upon 5 square. So this square can be broken into numerator and denominator. So this square, I use this square here and then I used it here. Then this was a 2 and this became 2 square, and this 2 and this 2 cancelled and only 1 2 remained. This is here. 1 minus x square minus 1 whole square. I took the LCM 2 minus x square minus 1 whole square upon 2. This word was equal to the right hand side. So I've spent some time explaining this question because interesting question, less of trigonometry and more of algebra. Let's move to the next question.